Hey friend, this video is the second part of my free Hexasword course. I invite you to go watch the first part if you haven't seen it yet. I'm going to leave a link in the description. If you want to support me, you can grab the course from Udemy. You will have access to the project files and videos are also better organized there. Enjoy the video. Welcome back, guys. In this lesson, we are going to learn how we can ease the level making process. And sorry if my voice is a little bit off. I'm a bit sick again, but that's okay. Come on. All right. So what do we want? Let's just hit play and see what we need here. Whenever we place a stack on a grid cell, if we select the according grid cell or the concerned grid cell, we can notice that, let's switch to debug mode. Yeah. We've got a stack right here. And this stack does have a list of hexagons as we've spotted in the previous ones. So this is what we need. Okay, so we need two things. Assign the stack to the grid cell and assign the hexagons to the stack. Okay. So what we are going to do is create a little script or implement the existing scripts to have a list of colors in our inspector. Okay, so let's say the grid cell contains a list of colors, and depending on these colors, we want to spawn hexagons inside of a stack on top of the grid cell and assign the stack to the grid cell, assign the hexagons to the stack, and so on. Okay, so first off, let's open our grid cell script. We definitely need a reference to the hexagon because this is what we want to spawn. So let's add it, elements, serialize field, private hexagon prefab. Here we go. And we will also need a list of colors. So definitely the hexagon colors. So let's say header, yep, settings, or maybe data, serialized field, private color. This is going to be a color array. Let's call it hexagon colors. Perfect. Now let's add a way to generate the hexagons depending on these colors. So let's create a new private void, generate initial hexagons. Here we go. We can definitely call this color using the onValueChanged attribute from Naughty attributes. So let's add the library at the top here using Naughty attributes. And of course, we want to add the onValueChanged and call generate initial hexagons. Here we go. Let's make sure that it's the same naming. Yep, perfect. And inside of here, we need two things. We definitely need a stack because let's check it again. If I hit play here, let's drag a stack on a hex cell. Okay, or the same one. I didn't do it on purpose. But yeah, we've got a stack as the second child, okay? And the stack contains the hexagons. So we definitely need to create the stack first. Okay, let's do that. Let's write stack equals new game object. We can give it a name. So initial stack, let's say, dot add component of type hex stack. Here we go. Perfect. So this is our stack. We can definitely set the parent as this transform. So stack.transform.setParentTransform. Here we go. This is going to be the second child because we already have the grid hexagon as the first child. And we can also set its position. So stack.transform.local position equals, let's say vector3.0. Yep. At the center. Is it where we drop it? Let's try this again. Okay, boom, select the hexagon, the stack, yep, at 0.2 actually. So we need to elevate it by the hexagon depth. So vector3.up times .2f. Here we go. So now if we jump back to Unity, we should be able to generate the stack. But let me show you something here. Let's select the same one. Okay, let's add a color. And we already have two stacks here, which is really bad. If I change the color multiple times, you see that I'm having a bunch of stacks. So we definitely need to make sure that we only have one. Okay? So let's jump back to our script and write while transform.childCount is greater than 1. If we have more than one child, we're actually going to remove all of the initial stacks because we should only have the grid hex renderer, right? So transform t equals transform.getChild at index 1. Perfect. Let's rearrange this. Here we go. T.setParent null and destroy immediately t.gameObject because this method should be called inside of the editor and not outside of it. Later on, we will definitely make sure that we are inside of the editor for these. Okay, let's now try this out. No need to hit play. So let's simply change this color, and that's already way better. We now only have one initial stack when editing our hexagon colors. Perfect. So what should we do next? Now that we have the stack, we can definitely spawn our hexagons. So let's do so. For I from 0 to hexagon colors, hexagon colors, dot length, let's create the hexagon. So vector3 spawn position will be equals to stack dot transform point, again vector3 dot up times I times dot to f, again the depth of our hexagon. Okay, and now that we've got the spawn position, we can definitely spawn it. So hexagon instance, let's say, equals instantiate. Okay, here we go. The hexagon prefab at that spawn position, quaternion.identity for the rotation, and the parent will be assigned to whenever we add the hexagon to the stack. If we open the hex stack class, we can notice that when adding the hexagon, we actually set the hexagon as a child of the stack. So that's perfect. Okay, so we can remove this, add a semicolon here, and now set the hexagon color. So hexagon instance.color equals hexagon colors at index I, boom, like so. Oh, come on, why can't I type? And finally add it to the stack. So stack.add the hexagon instance. Perfect. Let's try this out. Let's go back to Unity. Okay, so we definitely need a reference to the hexagon prefab. Okay, we can actually select all of our grid hexes here. Okay, let's select our prefabs. Or what we can do is add it to the grid hex prefab, actually. That's way better, because now whenever we regenerate the grid, like boom 2, it's already added here. Perfect. So let's add some hexagons. Okay. You will have an error here because you should not instantiate a material in edit mode. That's okay, because if we use shared material, it will change the color for all of our materials. So for this case, it's okay. So let's create a stack of, let's say, 3 blues and maybe 2 reds, like so. Perfect. Let's now hit play and see what happens. If I try and drag and drop a stack on that grid cell, it's working, which is really bad. If I try and merge some hexagons, it's not working, which is also really bad. So what's wrong here? Well, if we switch to debug mode, we can notice that the stack is null, even though we've created it and assigned it in edit mode, but it has not been saved. And same thing here. If we select our initial stack, no hexagons inside of it. So we need to make sure of 2 things here, actually 3. We need to reference the stack at start, we need to reference our hexagons at start, and we also need to disable the collider. Because as you can see, the colliders are still active here, which is not what we want. We will be able to move them. You see, here is another error. So in the next one, let's fix these 3 steps. See you there. Welcome back, guys. In this lesson, we are going to complete our level making process. Okay, so let's first tackle our stack being null here. So if we switch to debug mode, yeah, it's still null, which is really bad when playing the game. So for that, I'm going to open the grid cell script and add the start method. So let's add it just before assigning the stack. Start, here we go. And at start, what we want to do is check if we've got more than 1 child. So if transform.child count is greater than 1, it definitely means that we've got a stack there. So we can write stack equals, not start, stack equals transform.getChild. So getChild at index 1, the second one, dot get component of type hex stack. Here we go. And then what we can do is initialize our stack. So stack.initialize. Initialize. Here we go. What's this initialize method here? Its main goal will be to add the hexagons to the list. So let's copy this name, open our hex stack here, and add the initialize method. So public void initialize. Here we go. And inside of here, we are going to loop through all of the children of this stack and add them to the hexagons list, because it means that we've created them in our grid cell here. Okay, so for I from 0 to transform.child count, let's add that child or that hexagon. Add transform.getChild at index I.get component of type hexagon. Like so. Boom. And we should be good. Perfect. Yep, that's basically it. But right now, again, if we add the hexagon here, we are not disabling the collider. So we should definitely place the stack right after that. So let's call the place method to disable the colliders again. Okay, let's jump back to Unity and try this out. Hopefully, if I click play, it should be good. We are going to check things one by one. So let's switch to debug mode. Okay, we've got the initial stack here. Awesome. If we select the stack, we've got the hexagons and we should not be able to move them. Really cool. No more collider that is active. So if I drag this and drop it here, we should merge. Boom, that's the case. Awesome. Really cool. So now making levels is really easy. Another thing that I want to add here is turning our grid cells here into prefabs, because when I try and select one in the scene view, it's really not convenient. It's selecting the render instead of this one if I want to disable it. So let's say you want to make levels, you want to disable this one. Well, I've removed the renders instead of the grid hex, which is not good at all. So for that, let's regenerate our grid. Oh, by the way, we should switch to normal mode too. Here we go. And yep, let's turn these into prefabs. So for that, we need to open our grid generator. Cool. And when generating the grid, because this method should only be called in edit mode, what we're going to do is use the prefab utility instead of the simple instantiate method. So let's do so. Let's comment this and add the Unity Engine.editor library. So using Unity Engine, Unity Editor, sorry, yeah. That, like so. And just like that, you've created an error here because this script references the Unity Editor library and it is attached to a game object in your scene. So if you try and play it on a real device, you will definitely have an error. Oh wait, it might work because we are not using the library here. But if I write something like, let's try the first line actually. Let's write game object, let's say grid hex instance will be equals to prefab utility dot instantiate prefab. Okay, like so. Let's pass in our grid hexagon. So hexagon, perfect. We only need to cast this into a game object. Boom, game object. Okay, and we are now using the Unity Editor library. So we might have the error right now. Let's try that. File, build settings, let's build our game, let's call it let's say, I don't know, maybe blah blah, dot blah blah. Really original naming conventions here. And here we go, we are already having errors. Okay, so the first one is the name prefab utility does not exist in the current context. Of course, because when building the game, we are not including editor libraries. So to fix that, what you need to do is add a preprocessor directive here. So if Unity editor, then we can use the Unity editor. And you know what? Because we are only using the grid generator inside of the editor, we can encapsulate our whole script. So end if. Here we go. So let's go on now. Cool. We can actually try building the game later on just so that we can save time here. Okay, so let's now go on and assign the position, rotation, and parent to our grid hex instance. So grid hex instance dot transform dot position equals spawn pause. Grid hex instance dot transform dot rotation equals quaternion dot identity, even though it should already not be rotated. And then grid hex instance dot transform dot set parent transform. Here we go. Let's now jump back to Unity. Let's close this, select our grid generator. Here we go. Let's now, let's expand it. Perfect. Let's set 1, and we can already notice that we are spawning hexagons. Really nice. 2, and now if I select 1 in the scene view, I'm selecting the grid hex and not the renderer. Awesome. This is exactly what we want here. Cool. So yeah, we've already achieved a lot here. Nice. And I think we are good for level creation. You can now remove some hexagons, boom, boom, something like that. Hit play. It should work properly, like so. Awesome. Nice. And if you want to save this level, what you can do is turn it into a prefab. So you can open the prefabs folder. Let's create a folder for our levels. Boom. Let's grab the grid generator, drop it here, and remove the grid generator script. We don't need it anymore. So now, as you can see, we've got the purplish color. Let's try and disable the grid generator and drop this here. This is the case because our hexagons here have no material. If we select the renderer, none for the material. And if we hit play, it's still not going to work because, again, the material does not exist. So what we need to do here is to regenerate our hexagons at start. And for that, let's open our grid cell thingy here. Okay, stack, so on. What we can do is actually call the generate initial hexagon. So generate initial hexagons method. It should create the stack, assign it to our element here, and yep, we should be good actually. We might be able to remove this. But what this will do here is assign a stack even though we don't have any color or initial colors. So let's do this if we've got some hexagon colors. So if hexagon colors that length is greater than 0, then we should generate the initial hexagons. Okay, otherwise nope. Okay, let's now hit play, and our colors have been fixed here. Really cool. And we can also drag and drop stacks. Nice. Awesome. I love it. Cool. So this is now working perfectly. Really cool. Okay, so in the next one, let's tackle our main menu shader. See you there. Welcome back, guys. In this lesson, we are going to tackle the main menu shader from Hexasword because I really like it actually. All right, let's tackle this. So first things first, I want to create a new scene. Okay, so let's duplicate this one. Let's call it main menu shader. Let's open it. Cool. We can remove the managers, everything except maybe the camera, the lighting, and the ground. Boom, perfect. We can change the color of our ground here. So let's duplicate the material, call it ground 2, assign it really quickly and change its color to, I don't know, something a little bit darker. So let's reselect it. Okay, maybe something like that. Are we good? That's decent. Perfect. But first off, let's actually grab the 3D object we're going to use for this shader. I want to use this tower here made by Maxim Batirev. Sorry if I've butchered your name, sorry, but thank you very much for sharing. So let's download the 3D model here in FBX format. Okay, let's save it somewhere around here. All right, and when it's downloaded, we are going to unpack it. So let's open the folder here. Okay, let's extract everything in here. Boom, what do we got? What do we have here? The textures, okay, we don't need these. Actually, we are simply going to use the source. And because all of the objects here are inside of the same 3D mesh, what we're going to do is open Blender and edit the mesh a little bit, okay? So here we are. I'm going to select File, Import FBX, and open our file here. Boom. Here we go. Perfect. So we've got all of our elements, and because I only want the tower and seems like it is split in multiple parts, what I'm going to do is delete everything that I don't want, like so. Boom. And to select everything, by the way, I've pressed B. Okay? Box select. Nice. So now let's press A to select all of our meshes here, and then hit Ctrl J to join all of our meshes into one mesh. So this mesh will have multiple materials, but that's okay. We are going to use all of these. Let's keep them as they are. Okay, so now let's move this point to the center, 0, 0, 0. Here we go, 0 for the rotation too. Okay, let's just jump to side view. Seems like some elements here are below the axis or below the plane. So what I'm going to do is press Tab to switch to wireframe mode or edit mode actually. Press Z and select wireframe. Alt A to unselect everything, and B to select all of the bottom vertices here. These ones, okay, should be, yeah, all of them seem to be selected. Perfect. So let's switch back to side view by pressing 1, 3, or I don't know, remember the other one, but let's press 1 and press SZ0 to scale them or align them on the Z plane. Perfect, let's press enter. Then we can jump here and set the Z position, global Z position actually, to 0. Perfect. So now they should all be at Z equals 0, which is really important for our animation because we are actually going to use the position of the vertex along the Z axis to change its color. Okay, so now everything seems to be correct. So we are going to press Ctrl A and apply all transforms. Nice. Let's now export this model into Unity. So File, Export, and export it in the same folder. So let's export the selected objects, of course, and make sure that you've selected the element. Oh, we should have renamed it, by the way. Yeah, let's rename it Tower. So File, Export again, FBX. Let's jump back to our folder, selected objects, and apply the transform to. Nice. Let's export it as tower.fbx or simply tower. It's actually going to add the extension by itself. All right, let's now jump back to Unity. We will need to import this model. So we've got a models folder. Let's grab our element here. Here it is, tower, boom. Again, boom. Okay, it's not working. Come on. Anyway, what I'm going to do is show this in the Explorer and drag it and drop it here. Control C, Control V. Here we go. Now that's better. So let's drag this boy and drop it in our scene. We will need to scale it up a little bit. And yep, here it is. Awesome. So let's rotate it a bit and make our scene a little bit prettier. And for that, honestly, I think I'm going to time-lapse this because this is really not important. Anyway, enough. I'm really not the best at finding good matching colors, but I'm sure you're going to do better than me. All right. Now that we've got our tower well set up, in the next one, let's actually create our shader. See you there. Welcome back, guys. In this lesson, we are going to create our shader and try and play with it. Okay, so inside of the materials folder, we are going to create a new folder for our shaders. Here we go. Let's right click, create a new shader graph, URP, and let's use the lit shader graph shader. Okay, let's call it, I don't know, feel, something like that. Really simple, but at least it's straightforward. Okay, and what we want to do is assign this shader to all of our materials. So the materials of our tower here. So let's select one of these, and right now they are integrated inside of the tower. So what you can do is select the tower, select materials, and extract the materials wherever you want. So let's extract them inside of the materials folder. Maybe we can create a new tower materials folder, something like that, and extract them there. Cool. And to fix that, we are actually going to select our model here and grab the materials from there. So let's use the search project-wide, search and remap. Everything has been assigned, apply, and yep, here we go. Now our materials have been found and reapplied. But of course, because we've unpacked the shader, the model here it's not working. So I'm just going to copy the transform here, copy the component, drag this, paste the component values, boom, and remove this tower. Here we go. So now we can play with these materials. Let's select all of them and assign the shader we've just made. So shader graph, fill. Here we go. And right away, we've lost our colors. To grab the colors back, here is a quick tip here. Let's hit Ctrl Z, okay? We can select this shader, all right. So it's the lit shader used, and we can notice that the color property name here is _base color. So before assigning the shader, we are actually going to create this property so that Unity can assign it automatically. So let's open our fill shader by double clicking it. Here we go. I'm just going to maximize this window. Let's add a property here, color, let's call it _base color. Here we go, let's select it and make sure that the reference has that name, okay? Let's now save the asset, minimize, open the scene, select all of our materials here, here they are, assign the shader, boom, shader graph, fill, and it's working. But we can't notice it, but the colors have actually been assigned. To notice the colors, we're actually going to grab our base color and link it to the base color node here. Save the asset, and boom, here we go. So we now have a solid base to play with our colors. You know what? I'm actually going to change the layout here so that I can better play with things. Okay, let's remove the animator from here. But first off, let's actually open the shader. So edit shader, grab it, drop it here. Okay, so that I can see my shader, the scene, the game, and so on. Perfect. We can hide this. Nice. Okay, so as I've told you previously, we need to have access to the Y value of our vertex position. So for that, I'm going to add the position node, position, and it should be in object space, not in world space. We can now grab it and split it because we only need the Y value here. So just to try this out, we can grab this Y value and drop it on the base color. Let's save the asset. And you can notice that we already have a nice gradient going from what seems to be black to something grayish. I don't think it's white, but it's actually grayish. And it's already really cool and stylish in a way, because you can now multiply this by a certain color. So let's multiply this by the base color, assign it, please, thank you, and save. Oh, yeah, that's decent. Seems like kind of an overpowered occlusion. Yeah, this is not beautiful at all. A quick way we could have done this is by creating a color here, color node. I'm just playing around. I like playing around when making courses here because you can learn so much. Boom, let's set a, this color maybe orangish. Save the asset. Yeah, that's decent actually. Nice. A nice gradient going from black to whatever color you've chosen. Anyway, we're going sideways here. No need to use this. All right, we've got our base color. We've got our Y position, okay? So I'm going to show you two ways we can achieve the effect in the main menu, okay? So for that, let's actually create another float. This is going to be the fill percent. Let's grab the fill percent and drop it here. What we want to do is compare our Y value with the fill percent. So I'm going to grab this and drop it inside of a comparison node, okay? You can drop it inside of the A input and this one in the B input. We want to check if B is less than A. And if that's the case, we are going to branch this, okay? And the output will be dropped inside of the base color. What does that mean? Well, Unity will compare these two colors and, oh, this should not be true. This should be in the predicate. And if the fill percent is less than the Y of our vertex, what do we want? It means that it's less than here. So the vertex should be colored in black, okay? So we can actually create another color for the off color. Off color, here we go, let's grab it, drop it here. So if that's the case, we should use the off color. If that's not the case, so if the fill percent is greater than the Y of our vertex, we want to use the base color. If we save the asset, we can notice that everything is okay. So let's try and select our materials. We can play with the fill percent here. Oh, we've flipped our things. Come on, it always happened to me. So we can flip the less to greater here. So let's save the asset. Here we go. And now this is already really cool. You already have a nice fill shader. Nice, but we're going to go further, don't worry. First off, I want to turn the fill percent into a slider. So I'm going to select it and mode here should be slider from 0 to 1. Let's save the asset. Here we go. That's already way better to play with. Awesome. So in the next one, let me show you the second method we can use. And it's going to be a little bit more complex, but way better. Because in general, you should not use comparisons or if statements inside of shaders. It's not a good practice, honestly, but it works. For small shaders like this one, it works. So yeah, see you in the next one. Welcome back, guys. In this lesson, we are going to have a look at the second way we could have achieved the same result and actually a little bit better with another way, without if statements. So we will need our fill percent. We can diminish this, by the way. Let's remove the comparison, or maybe we can actually keep these somewhere around here. So let's drop them somewhere around here. Yep, cool. This is the first way. Let's not forget about it, actually. I'm also going to duplicate these two, the position and the split node. We are going to use the fill percent to our off color and base color, and no branch, no comparison. Okay. So first off, we are going to grab the Y position of our vertex and drop it inside of a step node. And this is going to be linked to the input, to the in input actually. The fill percent will be linked to the edge here. So the step node will return 0 or 1 depending on these two values. So if you play a bit with the default fill percent here, you can notice that indeed it does return 0 or 1. Okay, so let's keep it at 0. Okay. Then we can use this value to lerp between our two colors, as simple as it gets. So let's drop that into a lerp node. It should be linked to the t input, so the time input. We want to lerp between, and again, I'm going to make a mistake here, but I'm just going to link them, try it, and if it's not what we want, we're going to flip them. So let's now save the asset. Okay, come on, you must be kidding me. So what I'm going to do is add the 1 minus node to flip it over. Okay, we could have flipped the two entries here, but I just want to show you multiple ways again of doing the same thing. And again, it works really well without using any if statement. Let's try flipping these two, by the way, just to check if it's still working. It should. So let's save the asset. And yep, really nice. Awesome. So we've got less nodes here. All right, so that's the first step. Next, if you have a look at the shader in the original game, you can notice that there is a kind of an edge here, like the yellowish edge. And it's a really cool effect, actually. So let's try and add it. For that, we are going to add a new color. Let's call it edge color. And we're going to add a new float. This is going to be the edge width. Okay. So what we are going to do to use these is to actually grab our edge width and subtract it from the Y position. So let's add a subtract node, input A, let's drop the edge width here. And the default value can be something like .1, okay? So basically we are going to use the same logic, but with a smaller, let's say, Y position. So we will definitely need another step node with our fill %, so we can duplicate it, drop it inside of the edge, link this one to the input. Okay, I think we are good to go. And this step node will help us decide between the edge color. Okay, so let's link the time here, the edge color and the off color, this one, okay? Then we are gonna use this instead of the off color in our previous lerp. And we should actually be good here. Let's start, let's try this. Save the asset. Okay, can't notice anything. So what we're gonna do is select the edge width and change its color. So let's select all of our materials, increase this, decrease it, play a bit with it. Oh, the edge color is black, come on. Let's turn it or set it to red so that we can better spot it. Here we go. Okay. So we've got the edge, but it's not at the right position. So instead, we are going to flip these two boys here. Boom, save the asset. And yep, that's really nice. So let's set an edge of 0.01, let's say, or maybe 0.02. Yeah, that's decent. Okay. And let's change the color to yellow. And now, if we increase it, we've got the same effect. Really cool. We've got our edge, and you can actually add more colors if you wish, but I think one color is enough here. Nice. So now that we've got this working, I'm going to play around a little bit and add another layer of complexity. I want to bump the tower whenever we fill it, okay? So for that, what we can do is open our animator tab. Okay, here is our inspector. I need the hierarchy. Can I have the hierarchy, please? I'm going to switch to the normal view, actually, portrait mode. Here we go. Here is my hierarchy, and I'm not going to bump the tower directly, but instead I'm going to create an empty parent and call this one tower animator, let's say animator, okay? We are going to add an animator component, of course. Let's create an animator somewhere around here. So folder, animations, thank you. Right click, create a new animator controller, tower animator. We can now grab this boy, assign it to our tower animator here, and create a new animation. So for that, I definitely need the animation window. Here we go. Boom. I'm going to create a new animation. Let's call it a bump. Okay. Let's start recording, select the animator, and add a keyframe to the scale here. So we're going to start at 1. We can actually, it's actually going to be really subtle. So maybe somewhere around 20. I think it's too much, but let's try this out. I want to diminish the value along the x-axis, so 0.97, 1.03, let's say, and 0.97, just to make it kind of bump. Yeah, something really subtle like this. Let's hit play. Yeah, that's okay. We can make it faster, actually. Let's select everything and move it somewhere around here. Yeah, that's better. Here we go. Nice animation. I'm also going to select the animator here because I don't want it to play right away. I'm going to create a new empty state and set this one as the default one. The bump animation should loop, perfect. And we are going to make a transition from bump to new state. Okay, so whenever we are done bumping or animating the tower, it should jump back to the idle state. I'm also going to select the transition here because I want to have only one bump animation and right away switch back to the new state. This should be the transition. Okay, nice. Okay, so this is done. Now what I'm going to do is create a new script, attach it to the tower to control everything here. We need to control the field percent for all of our materials. So let's create that script. Scripts, right click, create a new C# script. Let's call it tower. And let's assign it. Okay, so I'm going to assign it to the tower and open it. Here we go. So what do we want in here? Well, whenever I press, so if input dot get mouse button 0, I want to fill the thingy, the tower. So I just want to mimic the behavior of the fill process in the original game when you press the button. So private void fill. So inside of here, I will definitely have some kind of fill percent. So fill percent plus equals a certain amount. Let's say fill increment. Okay, we can create these two. So header settings, private float fill percent. It's going to start at 0, but we can turn the increment as a serialized field, private float fill increment, so that we can tweak this value. Okay. What we want to check also is if our fill percent is greater or equals to 1, we can return because no need to go over 1. Then we definitely want to animate our element or our tower whenever we fill. So let's add a reference to our animator. Element, serialized field, private animator, animator. Let's write animator dot play. We want to play the bump animation and it should jump back to the normal or idle animation whenever it's done. And right here, we also want to update our materials. So we need to reference these. So let's add a, we can add it as a serialized field, or maybe let's just require that component. Type of renderer. Renderer. Here we go. Okay, so private renderer. Let's add the awake method. Render equals get component of type renderer. Here we go. And we want to update our materials right here. So update materials. Let's create that method, private void update materials. And inside of this method, we want to pass the fill percent to our fill percent right here. So we need to know the reference of that value or property. Where is our shader? Let's right click, edit the shader. Here we go. Let's select fill percent. And here is the reference. So we are going to copy it and use it inside of here. So inside of here, we want to loop through all of the materials of our render. So for each material in render.materials, and we want to set its float or the fill percent. So set float fill percent with the fill percent. No, come on, fill percent. Don't be dumb, please. Thank you. And we should be done. So let's try this out. Okay, we can actually update the materials at start, like so, because our fill percent is 0. Yep, boom, bam, boom. Should be nice. So let's try. Let's jump back to Unity. Okay, let's reference our animator, which is right here. Perfect. The fill increment can be something like 0.01, let's say. Let's diminish this and make this one a little bit bigger. Hit play. Right away, all of our fill percents have been set to 0, which is really nice. Okay, let's try and press the mouse. Boom. Yay. Working really well. Awesome. Let's try again. Wait for it, wait for it, wait for it. Yeah. So cool. And of course, you can still go one step further, add some little particles that jump from the camera, let's say, to the tower. You can add a fill percent indicator somewhere around here next to the tower. There is so much you can do here. One quick thing I want to add here, if you've noticed, when I increase the fill percent, let's actually select all of our materials first. Materials, let's select all of them and set the fill percent to somewhere around Yep, somewhere around here should be the maximum, 0.86. So we can tweak this. We can create another variable for our max fill percent. Okay, so this should be the maximum, and the maximum can be multiplied by the fill percent right here. So we are going to go from 0 to 1 times fill percent, which is our actual maximum. Let's select the tower, set the max fill percent to 0.869. Okay, and now if I hit play, okay, let's go on. We can actually press it, maximize it, and here we go, 0.869. And this is, oh, come on, sorry. Control Z, and this is our actual maximum here. It went over because of our check here, of course, but you've got the point. Okay, so this is it for this shader. It was really cool, actually, really helpful, and I love it. I'm not a shader guru, but I really like playing with these, and feel free to do so too, because it will drastically improve the look of your game. If there are other mechanics from this game you want me to tackle, let me know in the comments. I will be glad to do so. Bye-bye.